All right, guys. So let's talk about the respiratory system a little bit. I got respiratory pathology, and just before that, I just wanted to just go over a few things about the respiratory system with you. So it begins. Let me get my pen out here. It begins here in the oral cavity or the nasal cavity. That's where air is going to enter from. You guys did your oxygen trace. You should have started at one of those two places. Then it goes to the pharynx here. This is going to be the pharynx. You might have put nasopharynx if you were being super specific. If you were going to be super specific again after nasopharynx right here before the larynx, you would put laryngo. I think I did that wrong. Oops. This should be an A. Laryngopharynx. But really, for the health science class, we don't do this one or this one. We go right here to the larynx, which is the voice box or the Adam's apple. This does get larger during puberty. Kids find that kind of interesting. It's what makes the voice of males lower and more prominent. Other than that, my brother is going to be a laryngologist, so he'll be one of the only professionals in the state for the larynx in about a year when he comes back from medical school. Then air will go through the trachea. This has those C-shaped cartilaginous rings that will keep it from collapsing when you exhale. And then you're going to have this would be the left lobe of the lung, and this would be, or the left lung, and this would be the right lung over here. And we'll talk more about those in a second. Let's get rid of that real quick, put some muscles on. The primary respiratory muscle is going to be this muscle right here, which is the diaphragm. And when you contract the diaphragm, these muscles get closer together here and here and here and here and here. You can see how those fibers kind of run in those directions. So what's going to happen is that this muscle is going to get pulled down this way, and as it pulls down here, the lobes of the lungs here are also going to get pulled down, which is going to increase the volume. If you guys had taken physics, you would realize if you increase the volume of a container, the pressure will go down. As that pressure goes down, eventually the pressure inside the lungs becomes lower. So the pressure inside the lungs, the pressure there becomes lower than the pressure outside the lungs. And so air will flow into the mouth. It's kind of pushed by atmospheric pressure. That's why as you get higher, there's several reasons why as you get higher up it gets harder to breathe. The primary one is that there's less oxygen per liter of air, but the other one is that there's less air pressure. So it actually takes more effort to breathe in. All right, so that is the anatomy of the lungs. The other respiratory muscles are these right here. These are going to be the innermost intercostal muscles. Nobody talks about those hardly. I mean, you have to be in probably medical school. The next ones are going to be these intercostal. This is the internal intercostal muscles, and then you have the external intercostal muscles coming on there. And then if you add another layer or two, eventually you'll get to these sternocleidomastoid muscles, which if you're breathing really hard, these are the muscles that lift your shoulder. Oops. What I meant is that, not the pin one. These are the ones that lift your shoulders up if you're breathing really hard. You probably can imagine that if you've been an athlete ever. All right. let's leave this anatomy review of the lungs. We didn't get all the way to the alveoli, but we will get there here. So this is going to be a little bit of the pathology lecture. I've been going for, I don't know, a few minutes, maybe 3 or 4 minutes, and I'll keep going till I get to like 15, and then I'll pause, and I'll add another lecture later on, probably tomorrow, or maybe the day after that, or maybe even today, that you'll want to watch, and then I'll add some guided notes for you before I post these. So some of these, this was a medical school lecture that I've kind of edited, and it's got some great quotes in it, so something that eventually I'll do as a teacher is add quotes to my lectures. But this is a good one. The only place where work comes before success, or sorry, I'm reading it backwards. The only place where success comes before work is in the dictionary, and that's 100% true. If ever you guys think you want to do something, you don't tell yourself you can't do it until you've tried to put in the work. You're not going to be successful at things unless you got some amazing God-given talent, unless you put in the work. All right, anyway. So let's just talk a little bit about the respiratory system. It on each day it filters, moistens, and warms up to 10,000 liters of air. So 5,000 2-liter bottles. Oxygen and carbon dioxide is going to be exchanged with every breath. The full capacity is 6 liters, so 3 of those 2-liter bottles. And then we're going to kind of divide disorders or pathologies up in different ways. And this is primarily a pathology lecture. So you got upper respiratory ailments, that's going to be in this part. Sinusitis, that's inflammation of the sinuses. Pharyngitis, that's inflammation of the pharynx. So the sinuses are going to be up here and even like behind the nose, and then the pharynx is here, so that's pharyngitis, and then laryngitis is inflammation of the larynx, that's up there. You don't really see inflammation of the trachea. You could get things lodged in the trachea, but you don't really see inflammation of it. Then once we get down to the lower respiratory, you're going to get pneumonia, which we'll talk about. This is actually one of the leading causes of death among elderly. And then some chronic things like COPD, which is chronic obstructive pulmonary disorder. We'll talk a little bit about fibrosis because of cystic fibrosis. And then obviously smoking, which isn't a humongous deal among my generation or your generation, but vaping is. And it'll be interesting to see in maybe 10 years what the effects of vaping are. We don't know what those will be, and that will be interesting. I would not assume that the effects are none. If you think you can vape and not impact your respiratory system, you're taking a huge gamble. They simply haven't been around long enough for us to have done a long-term study. You're going to need to study people that have been vaping almost habitually for 10 to 20 years, and then study that for 10 to 20 years before you know what the effects are 10 to 20 years down the road. So I've known some really awesome students that have actually come and talked to me about being addicted to vaping. And that's the other thing that I'll say about vaping is being addicted to nicotine is stupid. This is a very addictive drug. It's not going to damage your life nearly as much as something like heroin, which I would say is more stupid. But it's going to not make you high, except for it gives you a tiny bit of a boost in energy at first, kind of like a caffeine boost. I won't lie, I've smoked a couple of cigarettes. I don't really remember how it made me feel. It wasn't something I wanted to repeat, though, because it made my lungs feel like crap. So that's kind of my little, let me get off that soapbox for now, and we'll move on. All right. Oh, shoot. Here we have gross anatomy coming up. The picture here Gross anatomy means basically that it's from a cadaver. If you look right here, I got the word cadaver down at the bottom here. And this one is actually one that might turn a few stomachs. So just be ready for that. You can skip this part if you want. Maybe skip ahead 15, 20 seconds. First, we'll look at the x-ray. So here you have a normal lung on x-ray. This part right here is, I don't know exactly what color to use on this. Let's see, let's try orange. This color right here is that would be the trachea. Then you would go to the bronchi. These right here would actually be where the bronchi enter the lungs. So it's going to split here, and you're going to have those bronchi, and then they're going to enter the lungs. And that's what you can kind of see right through. Let's see. Right through. I can't do that. There's no little thing. Right through all this stuff right here. The ends of the lungs you can barely see. Looks like I'm a little too high. Let's scroll up a little bit. Right here you can kind of see the edge. That would be the edge of a normal lung. Notice when I talk about pneumothoraxes or pneumothoraces in the future that will end up being more like here. The other thing is you don't see a lot of white in these areas. The reason you don't is because these are healthy lungs, not diseased lungs. All right, then here we have, this is the gross anatomy. This is from a cadaver. This is probably an elderly person that just didn't smoke. Actually, probably didn't smoke. Could have possibly smoked a little bit. But they could have been also living in a city. Like when Salt Lake gets really smoggy, I don't know the exact number of cigarettes it's like smoking, but it's like smoking 1 or 2 cigarettes a day. So here we have the stomach right there. So let's switch to black again. So that's going to be the stomach. And then here, underneath this is the liver. And then separating the abdominal cavity from the thoracic cavity. Abdominal cavity is down here. Thoracic cavity up here is going to be that diaphragm. This right here is pericardial fat, so just some fat. It looks they have not removed the heart. You'd be able to tell if they did. There'd be a big hole right in this area. The heart probably is something like this in shape. And then we have the lungs to the side. You're going to have 3 lobes on the right side. So you have an upper lobe, a middle lobe, and then the doctor will oftentimes palpate this on your back, kind of where you might think your kidney is, and that would be the lower lobe. And then on the right side, you only have 2 lobes. Sorry, the left side, you only have 2 lobes. So I think I mistook this. This would be the patient's right. This would be the patient's left. You got 2 lobes because the heart is over here more on this side, so there's less space. So you got the upper lobe and the lower lobe. And what you'll find is you can have diseases like pneumonia that are isolated to lobes. And you can see that in x-rays. So here you'd have the trachea, which would come down to about here and then split into those bronchi, which would enter the lungs and then split into bronchioles, which are little tiny bronchi, which then split into bronchial ducts, which is not something that health science expects you to know, but is an anatomy and physiology thing. And then lastly will be the alveoli. So that is kind of the x-ray and gross anatomy of a normal lung. This is a good picture right here that shows where, let me switch to white, white will work good. You have the trachea, the very end of the trachea. So this would be, your collarbone probably is up in here. and your breastbone coming down the middle. I don't want to draw that because that would be just above the trachea. That's going to break into these primary bronchi. These are your humongous big bronchi, so they're called primary bronchi. You don't need to know primary, just know them as bronchi. One of them would be a bronchus, which would then break into just bronchi, not primary, but just regular bronchi, which will then break into these little ones, which are bronchioles, which literally means little bronchi. And at the very end, which you can't see here, there would be like a little sack of grapes. Something that kind of look like a little sack of grapes. And those would be the alveoli. And that's where gas exchange occurs. So that's the end of the anatomy review. I think I'll stop this here and see how long this is and post this as the anatomy review.